Uh, Good morning, students. Today's topic of discussion is recurrent neural networks. Before delving into the topic of recurrent neural network, let us quickly understand what is a neural network. A neural network comprises of set of nodes or neurons. What is the use of neural network? Well, neural network is used to make system, AI system, to learn what? Learn the parameters so that the system could predict, predict or uh, classify or do certain tasks which are done by humans. For instance, if there is a cat image, there is a cat image. How do you know that it is cat? If there is cat, we know that means we humans know how cat looks, and then we can identify the cat. If we are shown dog's image, then we can identify that it is a dog because we know what is a dog. How AI system will learn means through machine learning. How through machine learning AI system would learn to identify whether the image has a cat or the image has a dog or it has anything else. So how is it done? This is done uh, by using various machine learning algorithms. One, for example, uh, we have SVM, we have artificial neural networks, logistic regression, and then linear regression, different decision trees, random forest. These are all classification techniques for making machine learn. Learn what? Learn various images or learn various text, various sentences. All right. So one among this method is a artificial neural network method. It has nodes like this, and these nodes have mathematical computations performed on the input. Input is some form of numbers, and then that numbers are passed on. Suppose this is the input x1, x2, x3. These are inputs. Every connection will have a weight from one node to another node. Weights are assigned for every link or every connection, and these connections would perform an operation of this summation of wi into xi. This node number 1 in layer number 2. This is first layer, this is second layer. In second layer, second layer, first node, it receives input from uh, previous layers, all the three nodes. So it has to do this. First, it has to do multiplication and then summation. Whatever value it receives, no, based on that value, it makes some decision. All right, that is uh, neural networks. In our last class, we covered different kinds of neural networks and components of neural networks. It has got input, it has got hidden layers, it has got output, activation function. Types of neural networks are single layer feed forward network, multi-layer feed forward network. Now the third type is recurrent network. Today we will learn the third type of neural network, which is known as a recurrent neural network. What is recurrent network? Recurrent network is another kind of network which has uh, some kind of connections in this manner. Normal feed forward network will have connections only in the forward direction. Layer 1 to layer 2 to layer 3 in this manner. This is feed forward. That's why from this type of connections, it has got its name, feed forward. It will move forward. Connections move forward. Okay. And then sometimes this kind of architecture is not very suitable. Therefore, another architecture was devised, which is known as recurrent network. In recurrent network, these nodes, this layer 1, this layer 2, this layer 3, layer 1 are input nodes, layer 3 are output nodes, layer 2 is a hidden layer. If you observe here this architecture, its connecting pattern, hidden layer node is receiving connection from both of its previous layers nodes, from here and from here. Okay, these two. And then these this will give the output on this line, which is connecting back. Output from the output node 1, output, this is output node 1, this is output node 2. Output node 1 is giving out the output as well as sending it back. Sending it back uh, to the network through its input nodes. Same applies with the second node in the output layer. It gives the output as well as it it sends it back to the input. You see here, this kind of architecture is entirely different from the feed forward. In feed forward architecture, in this is a feed forward architecture. Input is given to the hidden and then hidden to the output to the outside world. This is not sent back. Is the output sent back to the input? No. That's why it is feed forward network. And observe here, here it is sent back. This is known as a recurrent network. These recurrent networks have connections going back from output to the input nodes. And there are arbitrary connections between the nodes. Arbitrary connection implies to the fact that output layer nodes also receives input from these input nodes. Uh, when you consider feed forward neural network, this is not the case. In feed forward neural network, only a node receives input from its previous layer nodes, not from anywhere. Whereas recurrent network has this kind of arbitrary connections. And an internal state of recurrent network can be modified as sets of input data are presented. As new sets of input data is presented, internal state of recurrent network is also uh, changed. It modifies. And it poses a memory which proves to be useful while solving problems. It poses a memory means there is no memory like RAM or ROM. Please recall, we had this flip-flops. Flip-flop uh, behave as a uh, memory. You can retain the state in within flip-flop. So you can consider it as something which stores the information. Same concept is applied here as well. Because these connections are uh, done from back uh, from output back to input, this way some kind of information is retained, which is like sort of having a memory which will remember information in the network. Whereas in feed forward network, this is not the case. Feed forward network does not have any memory, it does not remember anything. It just passes on the input from one layer to another layer. It will not remember anything. Example, prediction of stock market price, weather forecast predictions. These problems require network with the features described for a recurrent network. And learning in the recurrent network involves feeding input through the network, which includes feeding data back from output to input. These are the important points uh, related to a recurrent network. And how is recurrent network trained? Trained means training a network is like making a small child uh, learn the colors. How do you make a 1 year old or 2 years old child recognize different colors, whether it is red or green or blue? You show. What do you show? You show various objects of red color, and you tell the child this is red color. Again and again, again and again, when you point to various objects around the child which are red in color, the child develops a kind of pattern and recognition within his brain, and therefore the next time if any object of red color is shown to a child will quickly recognize that it is a red color. How the child is recognizing that it is a red color? How do we know that this is R and this is E and this is C? Because when we were small, we were trained in schools and at home to learn these characters, letters, colors, and various other things. So that is nothing but a kind of training. Apparently, this kind of training is given to machine as well. When you train a machine, you show a machine picture of one cat and say that this is a cat, and then another cat and another cat. Like that, You show 1 million cat images. Then what machine will do? Machine would develop a kind of pattern or representation of cat in form of some numerical value. Uh, although still no one knows how patterns are created in human brains. No one knows how brain stores A or B or O or whatever. But we know how machine stores. Machine will create some kind of numerical value for every feature of this cat. And then what machine would do? Machine later, if a new cat image is shown, a machine could identify that it is a cat. How machine could identify that it is a cat? Because machine has been trained. Machine has learned. What machine has learned? Machine has learned various features of cat and has created some numerical representation of it. And when new cat is shown, machine could identify that it is a cat. Let me give you an example. I told you to follow some of the good challenges in Kaggle. In Kaggle, there is a challenge. The challenge is to recognize cats and dogs. Kaggle, cats and dogs challenge. Dogs versus cats. The name of this competition is dogs versus cat. An algorithm has to be created that would distinguish dogs from cats. If an image is shown to a machine should identify whether that image contains dog or a cat. For that, one data set is released. This data set has training and testing images. Okay, these training images are used to 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 specify the machine that it is a cat. For thousands and millions of times, you have to tell machine that it is a cat. Then the next time when a new image of cat is shown, machine can identify. You see, there are so many competitions in Kaggle. If you participate in these competitions, your data science skills will improve, and then you could showcase your solution to the recruiters, as well as you could win a prize. Uh, Here, this challenge, COVID-19 detection, the price of this challenge is $100,000, and the price for this show us the data, some discover something, Coleridge initiative. I don't know what is it. We have to read it. Some competition whose award prize is $90,000 US dollar. Like this, competition would have prizes, and this way you can develop very good skills. Let us see some of the images. That way you get the idea what is actually happening in the real world. We are studying all this, but where it is actually used. Look at this is one cat image, and then this is another cat image. Like this, you show to the machine different. This is another. Like that, how many are there? 12,500 images are there. 12,500 cat images and 12,500 dogs images are shown to the machine, and this is training. This is training process. After training is done, what is done? Uh, well, you have to test the machine. When children, KG children, are taught about colors and letters, then exam is taken, right? What happens in exam? They are shown with different letters and they are asked to identify what, whether it is A or C or D or Z or whatever. They identify that. That is testing, exams. Same concept is applied to AI systems development, which is happening in every domain, in every industry. Wherever you go nowadays, you see only about making machines learn various tasks done by humans. This is the most basic task, recognition, you know, differentiating between cats and dogs. There are several other tasks. Like example, given an X-ray image, system should identify whether that X-ray image has got COVID or not. That is also one challenge, and that challenge involves development of AI system by training it, by making it learn. There are some testing images through which system is tested. Again, there are 12,500 test images. Test images are those images which are not present in the uh, training data. A new image is shown to the system. So this is one a new image which is not available in the training data. All right, like this, AI systems are developed, and today the state of the art is neural networks. And then Hopfield Network is kind of recurrent network. It is invented by John Hopfield in early 80s. It consists of n connected neurons where all the connections are weighted and symmetric, means same weights. No unit is connected to itself. There are no special neurons for input and output. All neurons are both input and output. This is Hopfield network. This is another kind of architecture. Various architectures have been developed. I'll show you that also. Look at this. These are different ways in which nodes are connected, different architectures. This is also one such image that shows connection of nodes in different ways. This perceptron means single node, feed forward network, radial basis function, deep feed forward, recurrent neural network are these. Just now what we learned. After recurrent network, some more new architectures were defined which are not there in your syllabus, but they are available, which are long short-term memory, gated recurrent unit, transformers, attention networks, uh, deep convolutional network. All these are neural network architectures. These are doing wonders. You know, in Facebook, it can identify faces. That is also behind the logic is this neural networks logic. So this is very important area. Structure of Hopfield network is like this. We have some nodes, they have some connections, and there is an activation algorithm. This activation algorithm chooses a unit randomly and call it ith unit. Ith unit compute activation value. Activation value means what? Let us take an example. Suppose mm you get a message from any of your classmate. Today we are planning to go out at 5 o'clock. You, if you are not willing, you just ignore it. Means you are not activated. Suppose you get a message from your best friend. Today at 5 o'clock, let us meet. Then what happens? You are your activation value is increased and you get activated. You get activated and you take action. Likewise, every node in this neural networks would get activated, would have an activation value, and based on the activation value, whether it might trigger uh, an output depending on the activation value. So for ith unit, compute activation value as given below. This is the formula for computation. Sum of w of w sub ij into sj for all j, where sj is the state of the jth unit. For every node, this computation of activation is to be done, and if the sum is greater than some threshold value theta sub I of the ith unit, then the selected unit becomes activated. All right. If in your WhatsApp group, if suppose I post a message that tomorrow I am taking an extra class at 10 o'clock or 9 o'clock, then how many of you will get activated based on threshold value? What is the threshold value? Suppose at that time you don't have any other work, you are free and you are willing to attend, you have data, you have everything to attend the class, then that sum would be greater than the threshold value. Then you are ready for the class. There are some students who might have go to work, who might have some other responsibilities, some other thing, or network problem, data problem. Then their activation is not greater than this theta value. If it is not greater than theta value, they don't do anything. They just ignore. Okay, there is a class, but then I can't attend due to this or that. Likewise, every node in this Hopfield network would get activated based on the value. And then this is repeated. This algorithm is repeated. Choose a unit randomly. The unit may be active or inactive. And then for the chosen unit, compute the sum of the weights. Whatever we have done here, no? Sum of the weights. Here, weights. And if sum is greater than 0, consider threshold is to be 0, the node becomes active. Otherwise, it becomes inactive. Everything whatever you are learning in AI system can be relatable to the real world examples, because now everywhere whatever you do, behind that on the internet, there are AI systems. Okay, this is the current state. Based on the current state, value for every node is calculated. For this node, it is 3 minus 2 is equal to 1, because it is getting 1, and 1 is greater than 0, it is satisfying the threshold and it gets activated. And here when this is the node, here this one is minus 2, its value is minus 2. Because its value is minus 2, it is less than 0, so it gets deactivated. A stable Hopfield network means um, where we have more stable states that do not uh, switch between active and passive many number of times. Rather, they show stability. Only few nodes get activated and few nodes will not get activated. So these are some of the stable position. Here you see these are two activated node and one is inactive node. In this case, two activated and one inactive. Here these all are inactive. Something that is retained, that is there for long time, that is known as this active stable state. And to calculate how to find that stable state, consider a Hopfield network with 4 units and 3 training input vectors. Everything is numbers. Node means there is nothing like a small circle in the system. It is about some numeric values. It can be vector or it can be matrix. That's why it is said that for data science, one should be good at linear algebra, statistics, probability, calculus, because uh, the base for all these concepts are mathematics. These are 3 inputs, x1, x2, x3. These are their values, 1, -1, -1, 1. These the 3 vectors. And then based on this equation, uh, x1 into x1 transpose. X1 transpose means what? If it is 1 -1 -1 1, the transpose of this would be 1. This column would become row. 1 -1 -1 1. This is a column, whereas this one is a row. Now you can perform multiplication. Multiplication could be performed only if that matches. If you are doing, this is 4 by 1, this is 1 by 4. If these internal uh, dimensions matches, only then you can perform multiplication. So this, by doing transpose, you perform multiplication, you obtain some value, and you apply uh, a mask if it is there, to obtain the final result, which will give the uh, nodes states. States means whether it is active or inactive. Based on the, here this matrix, each vector in this matrix would represent one node, and then based on the values, you can get, if it is greater than 0, it is active. Active means filled in. If it is less than 0, it is inactive, means it is not filled in, it is unfilled. That is Hopfield network. There is another network. There is another network which is known as Boltzmann machine. Okay, this Boltmann machine is also a kind of network. The difference between the Hopfield network and this Boltmann machine is a name given to the derivative of Hopfield network, which is obtained by combining Hopfield network with simulated annealing search technique. There is a search technique called as simulated annealing. This and Hopfield networks, when they are combined together, uh, it gives rise to another type of architecture which is known as Boltzmann machines. And this was proposed by Hinton and Sosnowski in the year 1986. And the main point of difference in Boltzmann machine is that the units contained in this machine update their individual binary states by a stochastic rule rather than a deterministic rule. Based on the rule, they are updating the weights. Here we have learned that by performing these operations, and we have got the rule. What is the rule? Rule is if it is activation value is greater than 0. Based on the rule, based on the various computations, we are performing this updating of the node values. In Boltzmann machine, updation is done by the units themselves by using stochastic rule. Stochastic rule means deterministic is something which is known and which could be estimated from some values, whereas stochastic could not be estimated. It depends on the time, it depends on several other factors, and it's not predictable. And the formula for that is this one, which is used to find the value 1 over 1 plus e to the power of delta e over t. This e denotes the sum of the active input connections and t denotes the temperature of the network. Based on the temperature, it changes the value. That's why it is called as stochastic. And temperature also you can't predict, and it is not fixed. Morning you may have one temperature, evening you may have another temperature. If temperature is different, then this value temperature does not mean this weather temperature what we see. It's a value assigned to a network, so that value would be changing. Because of the change in the value, its output value is also changed, and it is not predictable. Applications of Hopfield networks are used as content addressable memory system, which are known as associative memory, and these are used to solve constraint satisfaction problems. Constraint satisfaction problems means these are those problems that involve some kind of conditions to be followed in order to perform certain tasks. For instance, game playing is a constraint satisfaction problem. If you consider this game of chess, you have to follow some rules. It's not like whatever you wish, you can't move and you can't change. You have to have certain constraints to be followed. Such type of problems are known as constraint satisfaction problems. Typically, you have games in that, and some other problems where constraints play vital role. In two types of, in these two types, these are the two applications for Hopfield networks. Okay. With this, we have done with that chapter. This chapter, advanced knowledge representation. Let me check. Students, if you have any doubt, you can ask in any topic from the entire syllabus of AI. Let me check which topic is there from this chapter. Advanced knowledge representation technique, 15.5 and 15.6. These are the two topics in unit number 5. Now we are in unit number 5. This all not included in your syllabus. Case grammars. Okay, students, will anyone tell me what is the use of grammar? Why grammar is needed and where is it needed? Why are we learning this grammar? Any example you tell me where AI systems are using grammar? Anywhere.
To understand the meaning, madam,
Yeah,
grammar means arrangement of sentences to make it more easy for the system to understand. Like you said, cats and dogs, right? There we need to provide some tags as well to understand the system, to let the system understand. There also it may help. We need to provide some description about that image, then only it will understand, because by looking at image it won't fetch any details, right? There might be some description attached with it.
Very good. That is a very important application of grammar where image is described uh, mm, by humans at the time of training, and later machine will describe an image at the time of testing. That is one right example, right application of grammar. Anything else? You think about it, I'll show you one more important application. Yeah, please, students, think about it. Vladimir, Vladimir is Halpeakod. Yes. See what he has tweeted. Hmm, this one. 10 hours before, can you detect COVID 19 using machine learning? You have an X ray or CT scan, and the task is to detect if the patient has COVID 19 or not. Sounds doable, right? None of the 415 ml papers published on the subject in 2020 was usable, not a single one. Let's see why. Last year, 2020, 415 ml papers were published on the subject of detecting COVID-19 using machine learning, and he claims that none are useful because some reason he has given. Like that, researchers from Cambridge took all papers on the topic published from January to October 2020, 2,212 papers. 415 after initial screening, 62 chosen for detailed analysis, 0 with potential use for clinic. Actually, in real world, there were 0 with uh, clinical usage. Why? Because he's saying small data sets. Getting medical data is hard. This is the application of artificial intelligence and machine learning in medical domain. He is giving the reasons also why they are not usable, because of small data sets, biased data sets, and training and testing on the same data. Look at the, it is X, red X. Why? Because if you train and test on the same data, that system is not of uh, any significant value, as it knows, and it knows everything. If it is trained on a particular data and tested on the same data, what's the big deal in that? And you just never do that, never. And they're unbalanced data sets, unclear
Excuse me, ma'am.
evaluation. Yes, yes.
Ma'am, who is this person, ma'am?
He's a data scientist. I
Okay.
follow, I think, 150 or so data scientists. These are data scientists. If you should follow important people, then you will know what is happening. For very great data scientists, for example, Andrew Nack, and then Fifi Lee, and then Goodfellow, and there are many. Uh, great data scientists who have invented many new architectures, and Jan LeCun, Geoffrey Hinton, and I follow all of them. So I get all notifications whenever they post any important related to this AI. This is another a new architecture, transformer architecture, which is the current topic in this neural networks and AI and machine learning. All right, students. So why I'm showing you all this? Because for you to feel what we are studying, are there any uses of this or not? There are several uses. Everything everywhere is based on uh, these only. You know, even governments are using this data science, machine learning for the prediction. Scientists, how they are predicting that third wave would come in this month, or these many mortalities would happen, these many cases would happen. IITs are doing a lot of work. They are predicting, they are creating models based on AI. Those models are able to most of the time correctly predict, and most of the time not predicting as well. So it's very a huge task. It's not simple. No one has come up with the answer of case grammar. The one which we use every day, Google Assistant, which is very useful in communicating in our natural language, which is English, and even it now understand local languages as well, regional languages as well. So there also grammars play an important role in making system understand that what we are speaking and what it wants to convey to us. If a system is sending some text message to us, and the chatbots are there. Chatbots are also example of these, where grammars and language vocabulary plays a vital role. You can have a conversation with a chatbot. You give a message or a question, you pose a question, it gives a response. How is it possible? Because it understands what you are asking. How does it understand? Are we following any syntax? Are we following any vocabulary or any keywords? No, our own language. If I say an apple was eaten by John, this is just an English language sentence. What is the meaning of this? There is a meaning. How do we determine the meaning? We determine by saying that what, who, where, when, all these questions when we address, we get to understand uh, the meaning behind this sentence. And then it has got a structure, uh, object, verb. Actually, we have those, uh, what are these, nouns and pronouns and several other things combined to form a sentence. When a sentence is changed in just a pronoun, the entire meaning might change. We humans can understand, mainly because we know the language very well. We have got some common sense. We can see the things, and then we can know sometimes meaning behind a sentence which is not explicitly stated. So all this because we can do it. But how machine would do all that? Mike saw the girl in the garden with a telescope. Mike saw the girl in the garden with the cat. Mike saw the girl in the garden with a fountain. What is the meaning of these three sentences? In the first sentence, perhaps Mike has seen the girl with his telescope. In the second sentence, it might mean that there is a girl with a cat and Mike saw both of them. In the third sentence, Mike saw the girl in the garden and the garden has a fountain. In the first example, telescope was with Mike. In the second sentence, cat is with girl and in the third one, fountain is in the garden. We know that because we know what is a telescope, we know what is cat, we know what is fountain. We can't say that Mike used fountain to see the girl, because fountain is something, you know, which is available in the gardens or parks and all. We know, humans. So it is very difficult and tedious task to make computers or AI systems understand the sentences spoken or written in natural language. Natural language sentences have several meanings. It is not straight away. It's not like select a star from employee where ID equal to 10. That is very straightforward query. System knows there is a table called employee, in that there is a record with ID 1. It just goes it, fetches it and retrieves and prints. But in natural language, in natural language, you may say that uh, bring or print the data belonging to employee whose ID is 1. There is no proper format. The sentence might be spoken arbitrarily. Words may be placed here and there. Actually, if I have to ask whether you are able to understand or not, what you say, what I say, what I have to say, do you all understand? But what I sometimes what I ask, understand? Just understand means you will know that I am asking whether you have understood or not. There are so many intricacies and complexities associated with uh, language understanding. When a sentence is spoken, in that there is a agent. Agent is the instigator of action. Object on which action is performed, and there is a dative animate entity affected by the action. When you perform an action, the one who gets affected is dative, experiencer, an animate subject in the active sentence with no agent. The one who observes it, experience it. Beneficiary, who is benefited by the action. Location, place of the action. Instrument, how are you performing the action. Co-agent, if there is any other agent who is performing the action. Time, when the action is performed. Tense, uh, tense of the action, whether it is still being performed or was performed or is going to be performed. So these are all necessary elements in order to understand the case grammar. So one example is given: eat. Eat means agent would eat an object. Object is something eatable. Give, agent would give some object to some beneficiary. Okay, like this. Action means what was the event. Agent, who did the event. Objective, what was involved in doing the event. Why it what is the objective of doing the event. uh, whom was it done, when it was done, where it was done. All these questions, all these things addresses the uh, question of understanding the sentence. Okay, please go through this. Tomorrow we'll look at semantic web. Let me take the attendance because we have to record all the students who are attending. Roll number 2, 3, 10, 26, 36, 42, 44, 43, 51. All right, students. If you have any doubt, you can ask, or we'll meet next week. Bye bye.
Thank you, ma'am.